All right, let's pull back the curtain on something you might think you know: chemistry. Forget the boring high school classes for a second. We're going to talk about chemistry as the invisible architect of, well, pretty much everything. It's the force that has shaped our entire world.
So here's a question for you. What's the invisible thread that connects ancient Greek philosophy with the phone that's probably in your hand right now? The answer, of course, is chemistry. And today we're going to follow that thread all the way from humanity's first wild guesses about reality to our power to actually build it ourselves.
Okay, so our story has to start way, way back. We're talking ancient Greece, a time of pure thought, where the very first attempts were made to crack the code of matter itself.
Can you imagine? For almost 2,000 years, this was it. This was the best theory we had. The idea from Empedocles was that everything, literally everything, was just some combination of earth, water, air, and fire. It was simple, it was elegant, and it was based completely on philosophy, not a single experiment. That way of thinking would dominate science for centuries. And that idea led to another really powerful one: vitalism. See, for the longest time, people believed there was this hard line, this wall dividing the universe. On one side, you had the non-living stuff, rocks, minerals, and on the other, you had living things, which were supposedly powered by some mysterious, vital force. The thinking was you could never cross that line. You could never make a living chemical from non-living parts.
But, science is all about challenging old ideas. And in 1828, a German chemist, Friedrich Wöhler, was just messing around in his lab. He was trying to make one chemical, but instead he accidentally created something else entirely. Something that, according to the theory of vitalism, should have been totally impossible.
This was the aha moment. He wrote that letter, and you can just feel the excitement. Wöhler had made urea, a key compound found in living things, from plain old inorganic chemicals. He'd crossed that impossible line, and with one simple accidental experiment, the whole idea of vitalism just shattered. It turned out the same chemical rules governed everything, living or not. That wall came down, and modern chemistry was officially born.
So, with those old philosophical barriers gone, chemistry wasn't just about understanding the world anymore. Nope, it became about building it. This next part of our story is all about how chemistry became the engine of the Industrial Revolution. Now, I know this looks like a complicated recipe, but this is the recipe for one of the most important chemicals in all of history: sulfuric acid. Being able to make this stuff on a massive scale unlocked everything. We're talking fertilizers that could feed the planet, the steel that built our cities. This was chemistry leaving the lab and going industrial, literally building the modern world from the ground up. And then things just started moving faster and faster. In 1839, boom, chemistry lets us freeze a moment in time with the very first photograph. Then it let us pull fertilizer right out of the air, sparking a food revolution. And then, get this, a teenager trying to find a cure for malaria accidentally creates the first synthetic dye. He unleashed this explosion of color into the world that before then was only for kings and queens. But all this incredible new power, it had a shadow side. This next chapter is about that double-edged sword, how our growing chemical knowledge had the power to heal us, but also to harm us on a scale nobody had ever imagined. And it all started pretty innocently, believe it or not. There was this chemist, Humphrey Davy, experimenting with a new gas called nitrous oxide. He did what any curious scientist would do. He inhaled it, and to his shock, he felt amazing and just started laughing his head off. Before long, laughing gas parties became this huge fad for the rich. But a few people saw past the party trick. Dentists and surgeons realized these gases could do something absolutely revolutionary. They could stop pain. All of a sudden, surgeries that used to be pure torture became manageable. Just like that, chemistry conquered pain and laid the groundwork for all of modern medicine. But the very same industrial chemistry that created life-saving medicines also created unimaginable ways to kill. The knowledge used to make dyes and fertilizers was twisted, weaponized. Chemicals were designed specifically to burn skin, to choke lungs, to stop a person's body from using oxygen. This was the dark reflection of our new power. Chemistry turned against itself. And sometimes the curse was completely unintentional. To make car engines run a little smoother, a simple chemical was added to gasoline: lead. And yeah, it worked. But it also pumped a powerful neurotoxin into the air we all breathed for decades.
It took the work of one incredibly dedicated scientist, Claire Patterson, to finally prove how dangerous it was. The result of banning it? The UN estimates we have prevented over 1.2 million premature deaths every single year.
Now, here's a story that was basically lost to history for over 150 years. In 1856, long before anyone was talking about climate change, an American scientist named Eunice Newton Foote did a simple little experiment that had massive implications.
Her experiment was so simple, it's brilliant. She just filled some jars with different gases, stuck thermometers in them, and put them out in the sun. And she noticed the jar with carbon dioxide got way hotter and stayed warmer longer. Her conclusion, back in 1856, was groundbreaking. An atmosphere with more CO2 would make the whole planet warmer. She discovered the basic science of the greenhouse effect, but because she was a woman, her work was ignored, completely forgotten until just recently.
So, we've seen how chemists got really good at manipulating molecules. But here's the wild part. For most of history, they were flying blind. Atoms and molecules were just a theory, a powerful idea. No one had ever actually seen one. This final chapter is about the moment that all changed. Just pause and think about that for a second. Everything we've just talked about, creating anesthesia, synthetic dyes, all of it, was done by chemists who were working with things they could never, ever see. It was all based on brilliant deduction. But what happens when you finally get to open your eyes?
Well, for decades, the best we could do was indirect. It was kind of like trying to figure out the shape of a statue by only looking at its shadow. But then came atomic force microscopy, or AFM. And instead of looking at shadows, AFM is like having a microscopic fingertip, an impossibly tiny record player needle that can physically trace the surface of one single molecule.
And the result is, it's just mind-blowing. We can now take actual pictures of individual molecules. We can see the chemical bonds that hold our world together. All those diagrams you saw in textbooks, we can see them now, for real. It's the difference between looking at a map of a country and actually walking its streets.
This incredible new ability to see and to move matter atom by atom brings us right to the edge of chemistry's next great chapter. We're moving beyond just discovering what the world is made of to actively designing our future with it. So, we've come full circle. From thinking the world was made of 4 simple elements to taking pictures of individual atoms. We've created medicines that have saved millions and weapons that could destroy us all. We've built entire civilizations, and in the process, we've changed the chemistry of our own planet. The story of chemistry is really the story of us gaining this immense, incredible power. So the only real question left is, what are we going to do with it now?